Manas, you called to them? They asked money, Did not pick up. You gave missed call or call? Call. What about CCTV? It is under process. I told within 1 or 2 days I will get. Really, you lost your notebook, or are you checking whether CC camera is functioning or not? Functioning. Understood. Okay, students, once again, very good afternoon. So today, as per coming CPT, you have slowly. Should you ask permission, Ravi? First of all, for human beings, culture is important. Then only your talent, being a human being, you are failed. Understood, Amma? Okay. Culture in the sense how to behave in education institutions. Understood? Some culture you have, no one will stop your development. At least a basic sense, if you are coming, may I come in? Correct or not? This character will be affected to you only. Understood? Finally, if you entertain this culture, whether in your offices or etc., understood? No one will like you. Culture in the sense, so why? Because I should not teach these things. That is not my job. Okay, anyway, as per the coming CPT, what is the syllabus? Resistance, EMF and internal resistance and potential difference. Okay, so we'll talk on that. So first of all, you take any small element. If you talk any very small element, let us assume one small charge entered into this cross section. As I told you, if you have macroscopical perception, every charge has some constant speed. Please tell me what is the name of that speed? Drift speed or constant speed. Let's say the time taken to travel from position A to position B, let's say very small amount of time, delta t seconds. So what is the distance traveled by this charge? How much? B into delta t. The positive charge can encounter the collisions with the medium particles. Let's say the number density. What is the small n meaning? Not mole number here. What is the meaning of the small n? Total number of charges by total volume of that element. Please tell me what is the current flowing in this element? Total charge by total time taken. What is the total charge equal to? Tell me. Number of charges into charge of 1 electron divided by, let's say, time taken. Tell me how many number of charges can be accommodated by this entire element? You know, n equal to how much? Small n into total volume of the element I can write. I can write I equal to how much here? N into delta V into E divided by delta T. Tell me what is the total volume of this cylindrical element? Let's say the area of this circular cross section is some capital A. Let's say the length of the cylinder V into delta T. What is the volume of this element here? Area into length. So what I can substitute? Current equal to small n into, please tell me what is the volume of the element here? Area of the circular cross section into length. What is length here? V into delta T and into E and whole divided by delta T. So delta T here cancels out. So what is the total current? I is equal to small n into and area of the cross section into what is the velocity or maximum velocity acquired by any charge after the V is the drift velocity. Length equal to velocity to delta T, no? What is the velocity here? In the earlier session, I have explained what is drift velocity acquired after relaxation time. For suppose this is one atom, one charge encounter collision here. After some time, it is coming and colliding the second atom. Just before striking this, it will acquire maximum velocity. We are calling it as drift velocity. What is drift velocity? I am asking. V is equal to how much? U plus A into relaxation time. Correct or not? What is the meaning of relaxation time? Time taken by the charge to travel from here to here is called relaxation time. Tell me what is relaxation time? Initial speed equal to how much? 0. What is acceleration? E into capital E divided by mass. Force by mass. Force is nothing but electric force and divided by mass of that charge into tau. So substitute this drift velocity here. What do you get? E into capital E divided by small m into tau and into E. Okay. So I can write total current equal to N into A into E square and tau divided by M into E. If you take the area of the cross section, that's it. What do you get? That is total current by area of cross section. That is equal to how much? N into E square into tau divided by mass into electric field. What a total current divided by total area of cross section is called? Current density. It is called current density. J is equal to how much here? N into E square into tau divided by M into E. This is a very important law. It is called Ohm's law. Ohm's law of current. This is a very important relation between what? Current density as well as the electric field inside the two faces of the conductor. As it is very clear that if you twice the electric field, what is the effect on the current density? Current density as well as current also is getting twice. If you plot the relation between the electric field inside the current wire on x-axis and the current density on y-axis, exactly it is a straight line with a positive slope and passing through the origin. And the slope of this graph equal to nothing but what? This entire thing is called slope, which will describe the nature of the material. In any linear relation, the one and only one constant is what? The slope of that graph only. Which is constant? Your nature is constant. Your nature in the sense here, that wire, that conductor nature is constant. So that proportional constant, this entire thing is called proportional constant. Always in any proportional relation, the proportional constants will describe the nature of the material. Yes or no? Because material nature will never change. Copper will be always copper. Understood? If it allow million of electron means under any circumstances more than million electron it will not permit. That is its nature. Or understanding? That's what this proportional constant is called electrical conductivity. What is the name of that? This proportional constant sigma is called. Every value, every equation you have to remember. Sigma is equal to called electrical conductivity. Electrical conductivity of material. So what is the formula for the sigma equal to number density into E square tau divided by M. The reciprocal nature. Here actually if you understand the concept of this conductivity, see it depends on the number density, means the material which is having more number of free electrons. What is the meaning of the metal actually? What is the concept of the metal? Metal is nothing but it is the ocean of free electrons. How many types of electrons are there? In any atom, two electrons are there. One is bounded electron and other one is what? Free electron. What is the meaning of the bounded electron? How much energy if you give, that electron will not leave that orbit, will not leave that nucleus. But free electron is always out of the atom, always residing on the surface. Means the metal which is containing more number of electron, it will allow more electricity. Its conduction is very, very high. Vice versa also true, no? Vice versa means the reciprocal of this conductivity is called resistivity. So how I can write here? Resistivity equal to resistivity. Rho equal to nothing but what? Reciprocal of the conductivity is called resistivity. How can you define the resistivity? Equal to 1 divided by sigma value how much? N into E square and tau by. So the resistivity is nothing but M divided by N into E square tau. Okay, so whatever I am keeping star mark compulsory, you have to memorize. Okay, in intermittent calculations, it is very, very useful. Now, as of now, the current electricity is concerned, we'll talk about only one charged carrier. What is the one charged carrier? That is positive charged carrier. What is the meaning of the positive charged carrier? Is it true positive? Even though it is false, conventionally, still we are following current is nothing but flow of positive charge. So when current electricity is concerned, we will consider only flow of positive charge. But in semiconductor devices, current is contributed because of how many charged carriers? There are two charged carriers. What are they? Positive charged carriers, and other one is what? Negative charged carriers. Understood? So, which among these two charged carriers, which charged carriers will provide more contribution? I mean, more active, highly mobility, and which will contribute more amount of current, more participation? That is nothing but definitely electron only. What is the specialty of the electron? It has high mobility. The activeness of any charged carrier can be represented by one special parameter called mobility. For suppose this is one small element, small, very small conductive element, very small copper element. Here one electron is there and one proton is there. I applied same electric field. What is the meaning of the application of the electric field? This side I connected high potential, this side I connected low potential. Means I applied same amount of electric field. Understood? Now my question, which will accelerate very quickly? As we already have seen, what is drift velocity? Vd equal to E into E divided by M into tau. Or acceleration of any charged carrier, how much? E by M. Undoubtedly, the electron only will be accelerated more. Why? More acceleration because of least mass, which is having very least mass, that will be affected high in the electric field. That will be accelerated very quickly. That will acquire greatest speed. Right or not? So, with this all explanation, shall I write? Mobility is directly proportional to, or you can define, actually high mobility means under the less power supply. Even though if you supply very small amount of energy, even though if you supply very small amount of electric field, that charge should accelerate more and more. Then only you can say it is high mobility, na? Yes or no? Correct or not? For example, Nokia battery is there, some other mobile phone battery is there. Even though if you charge it for very less time, it will function for very long time. No? Correct or not? If you charge for very long time, functioning for great time, does not matter. Correct or not? Here, mobility means what? Even though if you supply very less amount of electric force, very less amount of electrical energy, if it is accelerating more, you can say that is high mobility. So how can you define mobility? High mobility means it should acquire very greater speed, even though if you supply very less amount of electric field. Understood? So you can define the drift velocity or maximum velocity acquired by any charge. Even though if you supply very least amount of field, then you can tell that charge carrier is high mobility or high mobile. Understood? So you can substitute B value also. What is the drift velocity formula here? E into tau divided by m into E. E cancels out. E into tau divided by m. What I put star marks in statement type questions, in theoretical type questions, in assertion, reasoning type questions will come. So you should know the relations. Then easily, very confidently, you can judge which is correct and which is incorrect. You can eliminate the incorrect relations. Understood? Your energy, your talent, not selecting correct option. You should judge which is incorrect also. Understand? Okay. So now, next one is cell, concept of cell. Concept of cell here or electric cell. Many types of cells are there. Holy cell, biological cell. Chemistry also, I think one cell is there. No? Battery cell, mobile cell, watch cell. This is not that cell. This is electrical cell. Okay. What is the name of that? Cell. Electrical cell. Okay, so Bharati in the first session she told sir electric potential is not in the syllabus. 2-3 questions I need bonus marks. Who told? Okay, anyway, leave it. So anyway, what is the cell here? Tell me. Huh? I raised the objection. You will get that one question is there, na? 29, I think. Usually after 2, that facility is not open. That software is not open. But right now you are very lucky. It is open. I objected. Definitely will get bonus marks for that. But what I am telling students, you did not inform me. That is showing your interest. Yeah, how many years after it's gone? Not this is 18th CPT. How many minutes it will take, sir? This question looks suspicious, sir. Please check. At least if you post me 10 questions also, no problem. Let it be correct also, no problem. But I will check. You will get your score will increase, na? Okay, anyway, someone tell me what is cell. Atharik, tell right. Atharik, tell right. Cell, tell me. Electrical cell. Stand and tell. Possess charge. Any other? Will you tell, Srinidhi? Many batteries make a cell. Did I ask what is the difference between cell and battery? Oh, if you tell answer, I should frame relevant question to that. Okay, sit both of you. Cell means what here? It is the barrier of electrical energy. Actually, what is electrical energy? Who will tell? You are telling electrical current. I am asking you electrical energy. Produced during solar. Listen to my question. What is electrical energy? Energy produced during? Come on, try. Kinetic energy of electron is called electrical energy. What is that? Sum of kinetic energies of all electrons that are flowing in a wire is called electrical energy. What is the role of electron here? Here electron is not energy. The role of electron is Cooley role. Cooley, you know, transporter, portal. It is a carrier of energy. It is what? What is the role of the electron? Just like a Cooley, carrier. It is transporting, it is carrying the energy from one place to another place. Now, those powerful electrons, those powerful ions in your chemistry language, those powerful ions which are preserved in the form of chemical energy in a cell, they are acting like a compressed spring. Correct or not? Some electrons, some group of negative charged ions, when you compressed tightly in a cell, what they are waiting for? If you compress in a spring, what it is waiting for? To release only, na? To acquire maximum kinetic energy only, na? Say yes or no? Similar fashion, the energy, I mean, the electrons, when you put them very, very closely, what is the meaning of that? Because of their repulsion, they are ready to release their electrostatic potential energy. Are understanding? The form of chemical energy, you compressed that negative charged ions, so-called free electrons, very closest distance. So the two electrons that you put very close, they are acting like a compressed spring. I mean the energy stored in the form of electrostatic potential energy between the two charges. Yes or no? If you connect that battery, if you connect that cell in a circuit, if you construct one road, what they will do? Because of their repulsion, they will acquire greater amount of kinetic energy. Understood? When it is entered into bulb, when those electrons are acquired maximum kinetic energy, when they entered into bulb, for example, what is the meaning of electrical bulb? Electrical bulb is nothing but which is containing high amount of resistance. Usually bulbs are made of tungsten metal. Tungsten, we know, it is having high amount of resistance. Yes or no? When that electron with high kinetic energy entered into tungsten, what tungsten atoms will tell? Come, go nicely like that, they won't tell. Correct or not? Resistant means that resistance atoms also tightly packed. They do not allow these electrons to flow freely. Correct or not? So between the electron and atoms, tungsten atoms, what kind of collisions taking place? Huh? Electrical collisions. Something we have to speak. Logic or illogic, we should speak. That's all. Okay. Anyway, that is semi-elastic collision. Correct or not? Say, sir, no. What is the meaning of semi-elastic? Definitely, in that collision, electron, less or more, it will lose its kinetic energy. For suppose, when it is entering into resistor, if it have 100 joule, we will not give guarantee when electron coming out of the tungsten, it will not have 100 joule. Are you understanding? For example, when it is coming out of the tungsten atom, it acquire only 70 joule before entering 100 joule. Where that 30 joules gone? Heat first. Heat. Understood? Actually, I should not call heat also. In the form of electromagnetic energy, it will be released. Electromagnetic energy means it can be a visible light, it can be any infrared light, or it can be any kind of electromagnetic radiation. Why it can't be X-rays or ultraviolet rays? I hope everyone understood. Is it clear, everyone? So that is the functioning of a cell. Now I will draw the block diagram of the electric cell. For suppose this is one cell. Cell is nothing but one small vessel containing how many volts, how many electrical diodes? Two votes are there. One is cathode and other one is anode. Near the cathode, all the negative charge ions has been accumulated. Near the positive node, all positive charged ions are accumulated. They are waiting for a situation. What situation? These electrons are waiting with a high amount of potential energy. They are waiting. Correct or not? The entire energy is stored in the form of electrostatic potential energy. Even same for nuclear bomb also. What a nuclear bomb? All the nucleons are tightly compressed. They are also waiting. Everyone put all your hands on the desk. Everyone. Okay. So they are also waiting for some situation. The entire energy stored in the form of what kind of energy? Here electrical energy is called electrostatic potential energy. The situation of these negative charged carriers means electrons, just like a people in a metro compartment, metro train compartment, or in a general compartment. Once station comes, how they get down from the train? If you create any path, what path? If you create any circuit, if you create any road for them, you put any device. Every device is called a resistor. Fan also resistor, AC also resistor. Every device, electrical device, electronic device, anything is considered as a electric resistor. If you put any resistor, what will happen? This positive charge. Current means our hypothetical discussion about positive charge only. Na? So these positive charges will come with a greater kinetic energy, and again they will enter here. Correct or not? There they are carrying the energy. What kind of energy they are carrying? Electrostatic potential energy to Kinetic energy. Once they strike the resistor, they lost their energy. Correct or not? So simply it is standing with a zero speed. Then who will attract? Again, this negative charge will attract. Again, once it comes to this negative charge, it is normal. Understood? Till entire chemical energy, who you have to think earlier, which energy made them to united? Actually, will two positive charge stays together? Voluntarily, will they stay together? Because basic fundamental like charges repel each other. Why the two positive charges kept closer, you have to think. Which energy helpful here? Chemical energy. Are understanding? As a kinetic energy is lost in the form of, earlier stored in the form of chemical energy. Correct or not? The atoms, the ionization energy kept them together. But as they are losing in the form of heat energy, do you think this chemical energy will be sustained for a long time? It is also will be dried up in a few minutes. Yes or no? If you look into the cell, as I told you, the positive charge entered again, many atoms are there. Many electrolytic atoms are there. If you take HCl cell, many hydrogen, hydride atoms and chloride atoms are there. Once this positive charge entered, this positive charge also will encounter collisions with this electrolytic atoms. Means here the electric cell is having two roles. One is role of cell, or one is role of power supplier or energy supplier, and another one is resistance. Correct or not? It is actually the positive charge is a family member of cell only. When it is entering, it is giving the internal resistance. That's what if you touch that cell also, for after functioning for some time, if you touch that cell also, it is getting hot because of internal resistance. So in the block diagram, this is the diagram, but in circuit diagram, crystal clearly you have to show it's a two function. One is carrier of energy, means like a just a power supply, and also it is having some opposition. What is sum of all opposition is called? Internal resistance of the cell. Is it clear? Understood? Name alone cell, but again, how many more devices are there in the cell? Two more devices. One is cell and other one is internal resistance. So these two devices together, you have to treat like a electric cell. And cells usually will connect for toy cars, remote controllers, etc. Those we are calling it as what? External resistance. You should not call this as resistance. Hereafter, during any circuit discussion, you must call it as external resistance. This is called internal resistance of the cell. Now, if you look into this cell only, when I am calling cell, when I am calling into cell, only you have to look these two terminals. So the potential drop across this, only two cells. Potential drop across the 2 points of the cell is called EMF. What is the meaning of EMF? EMF is nothing but potential difference or potential drop or voltage drop between the 2 points, excluding resistance. What is that? excluding resistance is called EMF. What is the if you expand this, what is the meaning of this? Electromotive force. Electromotive force. Correct or not? Is it motive or not? Once positive charge is entered inside the cell, it is automatically, it will be in the motion, because it is always in the motion only because of this electric potential drop. Correct or not? When the positive charge at negative electrode or cathode, why it is reaching the positive charge? To maximize the electrostatic potential energy. Inside the cell, its behavior is different, and outside the cell, its behavior is different. Inside the cell, it tries to acquire greatest potential energy. Once it is coming outside, it is trying to acquire maximum kinetic energy. Yes or no? Now, if you switch on this circuit, how current will flow? Always high potential to low potential. Then what is the potential drop across the cell here? Potential drop across cell. Potential drop means what? Across cell means, let's say this is potential X volt, let's say this potential is Y volt. I already told you, cell means cell plus internal resistance. Understood? The sum of the potential drop across cell plus potential drop across internal resistance is called potential drop. How can you define the potential drop here? Potential drop is defined as EMF of the cell. I mean potential drop across only pure cell. This is also called ideal cell. What is the name of this? Ideal cell. Ideal cell. What is the meaning of the ideal cell? Without internal resistance. So here meaning, cell meaning what? What is the meaning of the cell? Ideal cell plus internal resistance. This together is called a cell. Only the potential drop across ideal cell is called EMF. So what is the potential drop across cell equal to? Potential drop across ideal cell plus potential drop across internal resistance is called a potential drop across the electric cell. What is the meaning of cell here, everyone? Ideal cell plus internal resistance. Okay. Tomorrow we are going to discuss two kinds of functioning of the cell. One is the charging process. The other one is what? Discharging process. Okay. Today I will post some questions in WhatsApp group. Only 10 to 15 questions I will post. Everyone work out. Work very seriously. Your preparation only your weapon. Okay. Next time, everyone in the class 600 plus you have to get. That's all. This moment onwards, you have to think. You have to plan. Thank you. Bye.